practice problem. And in here, I have three groups of loads. I have group A, group B, and group C. And I'm asking you to figure out the overall power factor. What I advise my students in both FE electrical and PE power exam preparation is that use the decomposition and recomposition approach. Okay. So decomposition approach would basically be like you desynthesize the complex power into its real power and the imaginary power. And then at the end, you collect all of them and then you recompose them. Okay. All right. So 18 kVA at 0.80 power factor lagging. So remember, your complex power can be expressed in the polar form as a magnitude and angle theta, right? Same thing with this guy, same thing with this guy. So if I have 18 kVA, everybody agrees that that's going to be the magnitude. So let's throw 18 kVA over here. The unit of measurement is kVA. What about angle theta? The angle theta is not given to me, but what is given to me is the power factor angle, is cosine theta, right? Cosine of theta, power factor, right? It is equal to 0.80. So if I'm doing trigonometry, I can just do a cosine inverse on 0.80 and 36.85, thank you, 36.86 is the angle. Is this significant? Lagging, leading, lagging? Or can I just, ignore it? Remember our discussion, right? When the load is lagging, we have a lagging load, inductive load, the theta is going to be pointing upwards because the Q is pointing upwards, which means that there is a plus sign over here. And it is crucial. It is important to understand and appreciate this because you're going to see that when we start creating group B load, again, I'm going to do the same thing. Okay. So I'm going to take 8 kVA over here because that's a magnitude and then angle theta. When I go about calculating this angle theta using the same process, so the angle theta will be the cosine inverse of 0.80. Both are 0.80, both are giving me 36.86, but what's the difference? Well, the difference is that this guy is actually leading. And leading basically means that we have a negative Q. Okay, leading power factor, think about capacitors. Capacitors are sources of reactive power, and a source will always have a negative sign. A sink or a load would always have a positive sign. Is that clear? So I have to manually add a negative sign over here for this angle theta. Okay, and similarly 18 kVA we can decompose it. This is lagging, so it's going to be a positive angle. So the question is asking for the overall power factor of this manufacturing facility. So let's see. I have SA, right? 18, a positive sign because it's lagging, and that gives me this. Then I can break it up into its real and the imaginary component with P is equal to S times cosine theta. So this 14 basically is 14.40 is 18 times cosine of 36.87. And this guy is equal to 18 times sine of 36.87. But please pay attention to the fact that this is a positive angle because we had a leading power factor. Now, if you were wishy-washy about this, loosey-goosey, complacent, right? You had no, either you were rushing or you didn't pay attention or you didn't have that understanding of how to handle the leading. Check this out. You have 8 angle minus 36.87 because it's leading. So the P remains the same, not a big deal. But if you don't handle the negative sign over here, 36.87 for sine function, the sine function is going to result in a negative. Okay, because the sine of negative theta is equal to negative sine theta. Okay, and this can make the whole difference between you scoring a point on the exam on this question or losing a point on the exam on this question, because this component, because of it, the fact it's leading, is going to subtract, right? So similarly, I can go about S of C, which is 12 angle 41.41, and then that breaks up like this, right? So when I'm after the overall power factor, if I had not been paying attention to this negative sign, and if I was, plus or minus, I don't care, 50-50, toss the coin, and then I'm going to see. And, chances are that they may actually have an option on the exam if something like this is tested where they would present something with a positive sign, and just because you see something on the exam with a positive with that matches your answer doesn't really um, mean much, because that's a tripwire. That's basically a curveball. That's a pitfall. Okay. Now you collect all the real components together, right? This guy, this guy, this guy, and then you collect all the imaginary components together carefully, and that's what you end up with. You convert this from the rectangular form to the polar form. This is a magnitude, this is a phase angle. And if somebody asks you, comment on the nature of the final power factor, of the overall power factor, you're like, the angle is theta, theta is positive. I remember from Wasim's webinar that if theta is positive for the complex power, that is lagging, right? And our Q is also positive, so that this whole facility with the collection of groups A, B, and C is still consuming reactive power. Does it make sense? So this is a methodical approach that is built on a strong foundational understanding of what power factor is, what real power is, what reactive power is, what apparent power is, what power triangle is, what power factor correction is, what leading is, what lagging is. Okay, and once you have this level of understanding, you cannot go wrong. If you're new to this channel, please consider subscribing. On a weekly basis, I'm creating content for FE electrical and PE power exam preparation. I also discuss topics related to electrical engineering with a focus on power systems engineering. If you'd like to learn more about my FE electrical and PE power exam preparation programs, please visit my website, studyforfe.com.